In this section, we move on to deployment. Kubernetes designs pods as an ephemeral object. For example, pods will be evicted from a resource-starved node. If the node breaks down, pods on it vanish. This affects the stability and reliability of applications. Kubernetes provides controllers to manage pods. Deployment is one of the most common controllers. A deployment contains one or more pods, and pods are identical. Deployments ease application rollout and reduces operation risks. They can run unattended and support functions such as rolling upgrade. Let's look at the definition of a deployment. The first field is API version. The pod uses v1 and the deployment uses apps v1. Pod and deployment use different API versions. Next, kind, which is deployment. The following is the metadata, for example, the deployment name. Then, spec, the desired state of the object. The first field under spec is replicas, which indicates the number of pods. Setting it to 2 indicates that the deployment ensures that there are always 2 pods running. If you manually delete a pod after creating the deployment will create a new pod for you. If you create 3 pods, the deployment will delete one of them. The deployment uses the label selector to control pods. It matches the labels you specify, for example, it matches pods with the label whose key is app and value is Nginx. If a pod has this label, it will be selected by the deployment. The following is the template field, which is also called pod template. This field defines the pod, such as its metadata, image, spec, and container resources. The labels defined in the pod must correspond to the value of match labels above. Now, let's create a deployment. Run the deploy.yaml command to define the YAML file. Save the settings. Run the create command to create the workload. The command output indicates that the Nginx deployment has been created. You can also run the get deploy command to query the deployment. The digits indicate the number of pods. Here, 2 pods are ready, and they are available and latest. Then, we query the pods. You can see that there are 2 newly created pods whose names start with Nginx and are followed by a string of random digits. These 2 pods are created by the deployment. Let's check it out how the deployment maintains the quantity of replicas. I delete the first Nginx pod. Then, query the pods again. You can see that although the first pod is deleted, a new Nginx pod is created by the deployment 5 seconds ago. Deletion will trigger creation, and thereby the number of pods remains unchanged. How does a deployment control the number of pods? Technically, it uses an object called replica set. A replica set's purpose is to maintain a stable set of replica pods running at any given time. As such, it is often used to guarantee the availability of a specified number of identical pods. However, a deployment is a higher-level concept that manages replica sets and provides declarative updates to pods along with a lot of other useful features. Therefore, we recommend using deployments instead of directly using replica sets, unless you require custom update orchestration or don't require updates at all. Let's see how to operate replica sets. First, run the get deploy command to query the deployment. Run the get rs command to query the replica set. Do they look familiar to you? These are the name prefixes of the 2 pods we just queried. It means the deployment creates a replica controller first, and then creates a pod. If you run the describe command, you can see that there is a line called New Replica Set, which indicates the latest replica set associated with the pod. The command output also indicates that 2 replicas are created. The describe command is a useful command. You can also use it to query events of the deployment. Back then, when we created the deployment, we set the number of replicas to 2. What are the benefits of this setting? It could be very useful during upgrade rollback. For example, I want to change the image of the deployment. Run the edit command to replace the image in the YAML file. After the modification, the output shows the deployment has been edited. Run the get deploy command to check the deployment details. You may find no changes. Run the describe command again. You can see what has happened. The replica set of C6B5 is set to 2 at the beginning. 26 seconds ago, the new replica set named 7C5C was created. The number of replicas was originally 1, then gradually increased to 2. For the original C6B5 replica set, the number of replicas gradually decreases from 2 to 0. In this way, there are still 2 replicas, but the replica set is replaced from C6B5 to 7C5C. Let's check the replica set. For this new replica set, it is expected that there are 2 pods. Currently, there are 2 pods, and they are in the ready state. For the old replica set, the desired number of pods is 0, the current quantity is 0, and there is no ready pods. Let's take a look at the pods. The prefix of the pods has changed to the name of the new replica set. These 2 pods are freshly created, about 110 seconds ago. This is how a deployment is upgraded. There are some parameters you can configure to upgrade a deployment. Back to the YAML file. There is a strategy in the spec, which specifies the upgrade policy. The strategy has a type, indicating the upgrade mode. The first type is rolling update. In this mode, Kubernetes creates a new pod and then removes the old one. It keeps repeating this process until all your objects are upgraded. Rolling update ensures that there are 2 pods all the time. Your services will not be interrupted if there are always running pods. Another type is replace update. It deletes the old pods and then builds new ones. You don't need to set parameters for replace updates. In a rolling update, we first set the max surge field. This field indicates the number of pods that can be created, above the desired amount of pods. It can be set to a percentage, for example, 25%, or to a specific number. The max unavailable field specifies the maximum number of unavailable pods during the upgrade. If the value is 0, the old pod is deleted only after a new pod is created. If you want to roll back a deployment, you can run the rollout command. After we run the describe command, we can see the 2 upgrade parameters in the command output. Here, rolling update strategy. You can see the value of max unavailable is 25%, the default value of this field. That's because we didn't specify a percentage and retained to the default value when creating the deployment. We have 2 pods. 25% corresponds to half a pod. What will the system do? It rounds up the value and creates 1 pod. This quantity change is also reflected in the upgrade process. You can run the rollout command to perform a rollback. Run the rollout undo deploy Nginx command to roll back our Nginx deployment. Then, run the describe command again. The command output shows that the value of the number of replicas of the C6B5 replica set changes from 0 to 1 and then to 2. For the 7C5C replica set, the number of replicas changes from 2 to 0. This is the rollback process. Query the replica set again. The C6B5 replica set has 2 pods and the 7C5C replica set has no pod. Then we query the pods. You can find that the prefix of the pods has changed. These 2 pods are newly created, and the suffix of their names is a random number. In later use, you can easily create a deployment on the CCE console. We have gone through the console operations in the section of creating the WordPress and MySQL applications. Detailed instructions are available there. Alright. That's all about pod and deployment. Thanks for watching.